Alright, is the video on right now? Can you please confirm if the issues are sorted and once I get a go ahead, I will definitely start off with the session. Sorry for the confusion, there's been a bit of technical lag. Yes, thank you, thanks a lot for the confirmation. Alright, so just we will have the session from 8:45 to 9:20 today, just to make up for the time that we just lost. Good evening everyone, my name is Jesse Francis. And I am, those of you who have attended the GATE General Aptitude session that was conducted here, you might have seen me. And we'll go ahead with our session, not to waste much time. First 5 minutes will be an intro and recap, and then we will go into the topic. So we'll end the session today at 9:20, starting at 8:45. So today the session's titled Meet Our Real Friends. This is a part of a new Outlook series for CSIR-NET General Aptitude. Before we begin, just a small intro. Christy Sir, who is favorite to you, and I have authored a book, CSIR-NET General Aptitude, a new Outlook, and it is one of the best sellers at the moment in its category. I know most of you already have the book, and if you haven't got it yet and if you would like to buy it, you can find the link in the description. And most of the content we teach here, it is explained in detail with a lot of extra problems in this book. You can also find the Hindi version of this book in Amazon as well as the other publications. Going ahead, there is a rough schedule of the topics that we are going to cover, but we will definitely cover all the topics. Just that there may be a little shuffle of how they are covered, the order in which they are covered compared to what the list given here. Alright, so before we begin, I think you have already noticed how Christy talks about this. We want to be sure about why we are running this course, that's why we repeat it each time. We both studied together, and it is our passion for teaching that connected us and made us good friends. And we are planning to chase our passion for teaching, and we were working, Christy Sir was working with the private sector earlier, I was working in a college and a university earlier, and we had a lot of restrictions in chasing our passion. We were not allowed to teach in the right way, we were not allowed to teach students, inspire them to aim higher, and we decided that we'll try to chase our passion without restrictions. And also, as a teacher, the biggest reward we got as teachers ever is seeing you guys achieve your dreams. And through this coursework, we hope to assist you towards achieving your dream. And also, Christy Sir recently moved from the private platform, and I moved from my institution a few months earlier. And we have been constantly requested and loved by the love you guys have, my students and Christy Sir's students, all of you have shown. This is what motivated us to actually think about taking this course forward. And also the social obligation to build a better country, build scientists who are well equipped to lead our country forward. Alright, so to begin with, the course design, as Christy Sir had already mentioned, in minimum time, maximum learning. We will be focusing on theory and some questions, but more additional questions, solutions and quizzes will for you to learn at your own pace will be posted in our blog, and links are shared with you every day. Today, the links will be posted at 9 o'clock. We have expected the class to start at 8:30. Hence, by the end of the class, you will receive the links to the session notes. And more Q&A sessions is enabled by the chat section. So please use the chat. Christy Sir is alive and the team is also active, hopefully active by now. And you can use once the live is over, you can use the chat box, the comment box. Post your comments. We will try our best to get back to you as soon as possible. Going forward, you can always join the discussion. Search the channel name Christy's classes in Telegram, or you can scan the QR code here, or WhatsApp, send a message to this number, or you can scan the QR code. Again, you can access the study materials and all these links clickable through our website. So you can later, when you're rewatching the video, you can pause the video and scan the QR codes or access these sources later. Anyway, let's start with our session. It's about time. Today's session outline is a lot of familiar or less familiar words about numbers. We are going to explore them. Then we'll be exploring their precise meaning. I'll tell you why you need to know the precise meaning. And what we will do in this session is build up for the problems to come in upcoming sessions. We will look into we will look into some theory with some 1 or 2 sample questions. More problems based on this theory will be done in future. Well, why should we do it will be a good question, right? First thing is, questions may contain these words, and you should be able to, when you read the question, unless you know the exact meaning of those words, you may be tricked into wrong answers. We'll see some examples today. Some minor questions we never asked. These seems to be something we already know. We are going to talk about some minor questions we would have never asked. For example, is 0 a natural number? How many of you have thought about it? The first time I was asked about it, I realized that I don't know. I said, yes, it is a natural number. And you know what my teacher said? That was back in school. Because I thought I know natural numbers. It's a silly thing. But then the answer was something mysterious. We'll get to that soon. And suppose you have to identify in some question whether 19.333 is a rational number, and just that 3 doesn't stop here, it goes on forever. Is it a rational number? And is pi is equal to 22 by 7? Some trivial questions, right? Many of us know the answer to it, or many of us guess that we know the answer to it. We will try to answer those questions today during our session. We're saying interesting, but yes, but not in our country. Yes. All right. I'll get to that. Now, the story of our session today begins with someone named Leopold Kronecker. He was a scientist. We are all aspiring scientists or science teachers. So this interesting scientist / mathematician said something interesting. He said, God made natural numbers. All else is the work of man. Interesting, right? God made natural numbers. All else is the work of man. What does he mean by that? For example, let's talk about what is a natural number to begin with. Natural numbers are nothing but counting numbers. What do we mean by counting numbers? And what exactly did he mean by saying God made natural numbers? Counting numbers are nothing but those numbers we can count with fingers. Initially, when human civilization was evolving, all we needed to know is, oh, I had 3 food with me, or I had 4 stones with me, I had 1 stone with me. So they always counted from 1, 2, 3, 4, 5, 6, 7 and so on. But interesting, what made Kronecker say this? That's where we started. That's the reason Kronecker said it all started with natural numbers. But then the most groundbreaking creation came. That's nothing but 0. 0 is credited to Aryabhatta and Brahmagupta, and proudly we can say this idea was formalized by Indians. And people usually ask, How can people not know about 0? The thing is, often scientific discoveries are like that. Until it may be right in front of us. They used to say that there is nothing in my hand. They didn't know how to say it more precisely. They didn't know how to make it more precisely tell that there is nothing in my hand, there is nothing in it. So that's where Aryabhatta and Brahmagupta formalized the idea. And most beautiful thing about science is it is not done by one person or one country or one part of the world. The Islamic mathematician Al-Khwarizmi is the one who popularized this concept, which was formalized in India across the globe through his books. Beautiful, isn't it? That's the beauty of science. And then the Eastern world, the West, the European countries adopted it, and then the math started flourishing. That's a beauty. Look how we all contributed to the same cause of growth in mathematics, and it created wonders through math which we enjoy these days. Well, we talked about natural numbers, and then comes whole numbers. That is, natural numbers along with 0 are called whole numbers. So note that natural numbers does not contain 0. Whole numbers contain 0. This is how we perceive generally in mathematics. Alright. Now, going ahead, things were all fine. We were happy with whole numbers. Saying that I don't have any money was fine. But until one day I desperately wanted a Cadbury chocolate. And I didn't have money for it, and I asked Christy sir, can you give me, I didn't have any money, I had 0 money on my hand. And then I asked Christy sir, can you give me 10 rupees to buy chocolate? Now, what happened is, I had 10 rupee in my hand, but with which I bought the chocolate, but I had to give 10 rupee to Christy sir. And that's where the negative numbers came into picture. We needed negative numbers to express more ideas that we needed, that we needed to communicate. And hence we had negative numbers. So integers are the natural numbers along with 0 and the negative numbers. All the counting numbers, including 0 and the negatives of the counting numbers, form the set of integers. The word set is something we learned in the school, and if you don't know the word, don't worry. It's a collection. It's a collection of objects. We'll talk about it in one of the future sessions. Hence, we can say that -3 is an integer, -100 is an integer, 0 is an integer, 1000 is an integer, 1,346,000 is an integer. All of them, we can claim them to be integers. There are some terms related to integers that you should familiarize more. For example, set of positive integers are nothing but, we already gave that collection a name, that's natural numbers. 1, 2, 3, 4, 5 and so on. And most of the times the CSIR may prefer to use set of positive integers instead of natural numbers. Because if you remember, Veer Singh earlier pointed out that, is 0 a natural number? He said, yes, but not in our country. So they may prefer to use positive integers instead of natural numbers. But you should be familiar with all these terms. Negative integers are nothing but negative of positive integers that we have. And another term that usually confuses people is non-negative integers. Just like any other terms, not negative, non-negative. All those numbers which are not negative, those numbers are called non-negative integers. Similarly, there is one more term, you can guess its meaning, non-positive integers, that is 0, -1, -2, -3 and so on. So make sure that you familiarize yourself with these words. Going forward, things were fine with integers and negative numbers. Anyway, until all of a sudden we had a pi. I took a slice of pie, how much is left? I had cut a pie into 6 pieces, I took one slice of pie, how much is left? And we call that rational numbers. We write it as 1 by 6 and we called it rational numbers. Alright, so just answering the question which is asked, yes, today's session will be in English, but I do know a little bit of Hindi but not an expert in it. But we are working with our team who will be providing Hindi captions for these videos once the live session has ended. So for those who cannot follow English fluently, can definitely watch it with the subtitles. Anyway, going ahead, so 1 by 6, we wanted to talk about a portion of something, and that's where rational numbers came. Numbers of the form P by Q, where P is an integer, Q is a non-zero integer. Q is non-zero integer. Note that whatever is in the denominator of a rational number should be non-zero. There is an interesting story, maybe some other day I'll tell you about that. So such numbers are called rational numbers. Rational numbers can be written in many ways, and there are some terms which you may want to familiarize. One of the words is proper fractions. A proper fraction is a fraction where the number in numerator is smaller than number in denominator. Improper fraction is a fraction where number in numerator is bigger than number in denominator. And something interesting here, if you notice second improper fraction here, 3 by 1 is nothing but an integer. Every integer can be written as minus 3 by 1, minus 100 by 1. Therefore, every integer can be written as a P by Q form. Therefore, every integer is a rational. We also talk about mixed fraction, that is 7 3 by 4. Interesting, right? You should also familiarize yourself with how to convert between mixed fraction and improper or proper fraction. Improper fraction, and that will be covered in the next session by either Christy sir or me. And going forward, there are other ways to represent a rational number. It's nothing but 1.3567 is a rational number because if you notice after the decimal place, it ends after a few digits. If it forms an infinite pattern, for example, the second example here, 1.356356, and this pattern continues forever, that is also a rational number. Now, I'll address the questions pretty soon. Before that, let me talk about one more thing. It's almost like for every hero, there should be a villain. Don't worry, anti-rational is not the term, irrational is the term. Irrational numbers are not with the villains, they are in fact beautiful. Some numbers that are not rational, that is, any number that is not rational is called an irrational number. And that means it cannot be written in the form P by Q, or it can't have a expression like 3.141. It ends right after a few digits, after the decimal it ends. It can't have something like that. It has to continue forever without repeating the pattern. Such numbers are called rational numbers. Pi is an irrational number. E is an irrational number. With that small note, let me get to the questions quickly. How much left is 5 by 6? Wonderful. Yes, about the pi, if I take one off. good to train yourself with fractions. Fractions and rationals are almost synonymous. Now, talking about my language knowledge, I do know a little bit of Hindi and I do speak Tamil quite fluently, and but I'm going to stick to English because we'll use a language which is common to everyone. As I mentioned, good that you pointed out, we'll try to add Tamil and Hindi subtitles for those who want to follow, those who are struggling to follow English. All right, now going forward, this is something to get you thinking about whatever was taught till now. As I told you, I'll be covering theory today, and this is just to get you start thinking about it. Pi is irrational. Is pi is equal to 22 by 7? Good question, right? 22 by 7 is a rational number, but pi is irrational. So pi cannot be equal to 22 by 7. Pi is a rational approximation, that is pi 22 by 7 to some extent is to some digits after decimal is equal to pi. So we would always say pi is approximately equal to 22 by 7. This is something, but in CSIR-NET many questions you can solve by replacing pi with 22 by 7. But when you put 22 by 7 in place of pi, you are actually telling, I don't need the exact answer, I need some answer which is very close to it. Alright, beautiful, most of you have recognized it. Now, next question, is 0 a natural number? Remember, I told you how my teacher asked this and I didn't know the exact answer. I knew natural numbers, but I never thought, could 0 be a natural number? As many of you already answered, no. Or let me rephrase this question. Since I directly asked you, you may be thinking, oh, this is a trivial question. During the exam, if the question is, which is the smallest natural number given in the options? It's tricky, right? Some of us would automatically in the panic pick 0. That's where you need to assure that you know the real meaning of the terms like natural numbers, integers, negative numbers, positive integers, non-negative integers, and all those terms. So, just to sum up what we talked about right now. Yes, natural numbers are the counting numbers. Natural numbers along with 0 forms whole numbers. Whole numbers, natural numbers, the negative of natural numbers are called negative numbers, or a more precise term is negative integers. And all these all these numbers, natural number, the whole numbers and negative numbers together are called integers. Going further, every integer is a rational number. A rational number is nothing but a number which can be written in the form of p by q, where q is a non-zero integer and p is any integer. Further, like rational numbers when written in decimal form, it will have, after decimal it will have either finite number of digits or infinitely repeating number of digits. Those repeating pattern of digits, those numbers which does not have that, which will have infinite digits after decimal but do not show a repeating pattern, are called irrational numbers. Now, something interesting is these rational numbers along with irrational numbers are called real numbers. That's why we named our session as Real Friends. Okay, so if you notice, the box for irrational numbers is way bigger than rational numbers. There's a reason for it. There are more irrational numbers than rational numbers. You know, you don't believe me, all right? Because there is infinitely many irrational numbers, there is infinitely many rational numbers. One person actually said, there is infinity and there is a bigger infinity. Crazy, right? His name is Candor. Before we get to that, let me tell you, I forgot to point this out. Let me tell you this. What we have drawn here on the screen is called a Venn diagram. If you may know about this already. If you do not know about it, wait for it in one of the future sessions. Soon we will be covering the topic of Venn diagram. We'll get to it. So, going forward to Candor. Candor said there is infinity and a bigger infinity. People called him crazy. And to the extent that he couldn't get a job, his papers were not published, he was isolated. You know what happened? Interestingly, after his death, he died in a mental hospital because he was not accepted anywhere. He didn't have anyone to talk to. No, everyone said he is wrong. But what he found, he knew that it is right. Interestingly, after many years, now what Candor said is the standard theory that we follow right now. Especially as scientists, going to be scientists, or those who will be molding the future bunch of scientists, you should know one thing. Stand up for what you believe in, even if you are standing alone. Long as you have scientific and empirical proof, stand confidently for what you believe is right. It was told by someone named Sophie Scholl. She is someone who stood up against anti-Nazi. She is an anti-Nazi activist who stood up against it. So if you believe that your result is right and you have scientifically proven it, you as scientists should be confident to stand up. Like Candor, like Kepler, like just too many names out there who were told they were wrong in their lifetime but later were proven to be true. So this is not for you future scientists or teachers who are going to mold the future scientists. Getting back to our business, we were talking about real numbers, and now I'm going to focus my attention entirely on integers. I'm going to talk about two types of integers. This is interesting. This is something basic again, but you will need it for CSIR-NET. First is even integers. All those integers divisible by 2 are called even integers. You already know minus 100, 100, 1000, 1024, 2, 0, all of them are divisible by 2, hence even integers. Well, yes, Tesla is an interesting example, and yeah, it skipped my name. There are many more names in science. Going back, all those integers that are not even are called odd integers. Those integers that are not divisible by 2, minus 3, minus 1, 1, 3. Okay, all these sounds a lot mathematical. We know that many of us took other streams of science because we were scared of math. But math is a beautiful subject if I ever get a chance to convince you otherwise. Let's try it in a fun way. Pick any number, it's left to you. I am picking 8 and I have taken 8 chairs here. And what I am going to do is, I am going to try arrange these chairs in 2 rows in such a way that I can fit it in a rectangle. If whichever number I picked can be arranged in 2 rows in the rectangle like this, it is an even number. Hence, we can say that 8 is an even number. Let's try something else. Let's try picking 11. Arranging it in 2 rows, if you notice, it doesn't form a perfect rectangle. Let's try moving it around. Nope, it doesn't. Nope, it still doesn't. And thus, we can conclude that 11 is an odd number. Why this? This is something absolutely basic, but there is an extended use for it. Let's get to that. Let's take 2 sets of chairs, black chairs and white chairs. Let's see if we have, turns out we have even number of black chairs and even number of white chairs, right? Both are even numbers, and let's try arranging them together. That is, in mathematical terms, add them, and turns out When you add them, you have a perfect rectangle again. Therefore, we get an even number. That is, even integer plus even integer is even. Let's again take two sets of chairs and let's try arranging them and see what happens. Turns out both are odd numbers. Let's try arranging them, adding them or arranging them together. Turns out it forms a perfect rectangle again. That means we still get an even number, or in other words, odd integer plus odd integer is also even. Well, now similarly you can see that even plus odd, turns out it is odd. Odd plus even, turns out it is again odd. See how we are experimenting in mathematics? We take something, we experiment, we make observations. Well, this is a summary of what we noticed. This is something that you are taught to by heart since school, but now you know why it is true without memorizing anything. Even plus even is even, odd plus odd is odd, even, odd plus odd is even plus odd is odd, odd plus even is odd. Well, multiplication is nothing but repetitive addition. So, taking it forward that way, 8 into 3 is nothing but repeating the first set thrice. If you notice, we got 24. Well, something to notice here, it still made a perfect rectangle. Therefore, we can say that even into odd is even. And we can further see even into even is, turns out we get a perfect rectangle, it's even. Let's further do it. Odd into odd is, well, that doesn't look like it forms a perfect rectangle. Let's try rearranging. When after rearrangement, we are not able to form a perfect rectangle. Therefore, odd into odd is odd. To summarize, even into even is even into odd is even, odd into even is even, odd into odd is odd. See how the little trivial way of representing even and odd numbers helped us understand what we were made to by heart since childhood. Let me take my attention back to integers and further to natural numbers. Let's talk about natural numbers in particular. I am going to talk about two very important types of natural numbers. One is prime number. A prime number is a natural number which has exactly two positive factors. That is, that number itself and 1. Interesting, right? Why is it interesting? Look at the wording carefully. A natural number which has exactly two positive factors is called a prime number. 2 is a prime number, 3 is a prime number because it can be divided only by 3 and 1. 5 can be divided only by 5 and 1. What about the other number? Other natural numbers together are called composite numbers. Those numbers which is not prime are called composite number. Let me emphasize on this. A natural number which has exactly two positive factors are called prime numbers. A natural number which is not prime is called composite number. Notice the wording. I told you, right? You need to know precise meaning of these words to go forward. I'll tell you why. Let me ask a question. Is 0 prime? The question is the same question I asked a little earlier. Is 0 a natural number? It is not. Therefore, we don't check whether 0 is prime or not. Now, let me rephrase this question and ask you. The smallest prime number is, there is 0, 1, 2 and 4. Our automatic choice may be 0. But if we don't know what prime number is, what is the exact meaning of prime number is, but it is a wrong answer. Beautiful, most of you have got the answer right. Going forward, why is 1 not a prime number? That's where the wording of the question is very important. It said having exactly two divisors. If you do not know the word divisor, don't worry, we'll be covering it in one of the sessions soon. Exactly two divisors. One has only one divisor. That's why 1 is not a prime. Let me rephrase this question. How many prime numbers are there less than 10? Your answer will be harder, right? Is it 4 or 5? If you count 1 to be prime, you will get the answer wrongly as 5. But in real, there is 2, 3, 5, 7. There are 4 prime numbers less than 10. Again, another question. 2 is an even prime number. We talked about even numbers, we talked about prime numbers. Let's mix them up. 2 is an even prime number. Let me rephrase this question. How many even prime numbers are there less than 1000? That looks like a big number. I am waiting for your response. With that, I will, okay, there is one more question I can ask you. So, how many even prime numbers are there less than 1000? 0, 1, 2 and 4. Answer is there is only one even prime number. The reason is, if it is prime, it should have only two divisors, exactly two divisors. Any even number will be, can be, that number itself is a divisor, 1 is a divisor and 2 will be a divisor. Therefore, there cannot be more than one even prime numbers. But usually what people would see is, as sir said, rule out the irrelevant facts. Less than 1000, you will see less than 1000, you will be like, oh, this is scary, let me just leave this. Remember the tips and tricks we discussed earlier? Further, one more question and we'll summarize and end the session. Why is composite numbers not called natural numbers with more than two divisors? We call prime numbers natural numbers with exactly two divisors. Why didn't we call composite numbers natural numbers with more than two divisors? The reason is, then 1 will not be a composite number because 1 has exactly one positive divisor. The reason I am pointing out these questions is to get you start think. It's all trivial facts, but I am trying to phrase how the question paper setters are going to think about when they ask the questions. They are going to take a simple fact, twist it around, make a rubber balloon toy out of it. You may see the dog and you get scared, instead of looking at the facts, which is very simple. So we'll be doing more problems on this in the coming sessions. To summarize, we talked about our real friends, irrational numbers, rational numbers, integers which are also rational numbers, negative integers, natural numbers and whole numbers. We talked about exact meaning of those terms. In integers, we talked about even and odd integers, and further we talked about composite numbers and prime numbers. With a small summary, I will wind up this session. The summary for this class is already posted in the blog. You can scan this QR code to access that note. You can quickly ask any questions you have. Please post it in the chat box. Either I will quickly attend, or Christy sir, who is also active in the chat, will be attending to your questions. Or you can use the comment box in the YouTube once the live has ended. Use the comment box, post your questions, and if you noticed, we were trying our best to answer as quick as possible. I hope this session was useful to you. And next session, if you are inviting any of your new friends to attend the session, please tell them to watch through the session, because that will help you follow the session better, because these are the theory which is required for you to answer questions in the next session. Alright, thank you all. If there are any questions, I'll wait a few more minutes, 2 more minutes. If not, Please use the comment section in the blog as well as comment section in the YouTube or the channel or any of the other modes like the Telegram, WhatsApp or the website. Thanks a lot everyone. I hope you learned something new. I hope you got a new perspective about mathematics as well. Have a good day. Thank you everyone, and maths is a lot fun, and I know many of you might have had this fear when you started learning math, but it's a lot fun, and unfortunately our system doesn't let us teach in the right way. Difference between fraction and ratio, any guesses? All right, we will address that in the next session, but meanwhile you're welcome to put your thoughts in the comment box. Make a guess. In the next session, either Christy sir or I will be starting with a discussion on your questions, and please feel free to post your questions in the comment box, because we'll try from the next session onwards, we'll try to do it in such a way that we'll collect all those questions you asked, we address them before we start the session. All right, so with a small note we'll end the session. We'll try to add Hindi and Tamil subtitles to this lecture series pretty soon, so that those who struggle to follow English struggle to follow, because I know all of you can follow English. We will with practice learn, but in the process of learning, for you to follow it better, we will try to add Hindi and Tamil subtitles pretty soon. Alright, with this I'll end the session. 0 is not a prime number. Why? Because 0 is not a natural number. Alright, we'll end the session. Have a wonderful day. I am ending the stream now.